So exciting to be here. So WorldWide Telescope is a virtual universe that's populated by some of the highest resolution imagery of the sky from some of the best ground and space-based telescopes. So what we're looking at here is the Milky Way, which is a seamless image of the night sky. It's a trillion pixel image. And because it's a trillion pixel image, you can sort of get a wide view of the sky, and you can zoom right down into some real small details of what happens to be the Veil Nebula. But not only is there a visible light view, we have 50 different wavelengths of light from which to see that same portion of the sky, whether it's the cosmic background radiation, dust in the Milky Way, hydrogen alpha. I mean, if we go to X-ray, so if you're looking here, oh, there's a bright spot there. That's because that's a supernova remnant, and you can see the boundaries of where there was a explosion there a few thousand years ago. Not only do we have all sky imagery, but we also have a complete catalog of the public high-resolution images from the Spitzer, the Chandra X-ray telescope, the Hubble Space Telescope. You can look through any one of these, such as the Great Nebula in Orion, and we're trying to present the context. Where are these things? We've all seen these images, but does everybody sort of know where they are? And so this shows you that this is right below in the center of the belt of Orion, and if you zoom right in, you can start to see details you normally wouldn't see, which is a little proplet where a solar system is being formed. You're looking at the edge of a disk and a new star forming in the center there. So that's just a little bit of a peek into the nature of the imagery that we have in here, but wait, there's more. I mean, if you want to go look at the planets, well, here thanks to our collaborators at TEDxCaltech, here's a nice view of Mars, of course, but you know, what you really want to do is you want to be able to look at almost anywhere, and you can do that. We can even go down to the surface there and go right into Valles Marineris. We have a complete simulation of the universe here. So if we're looking at this view of the solar system, you can sort of see why Pluto is no longer a planet. But if we pull away from our solar system, you can start to see the stars move away from us, and pretty soon we exit the Milky Way, and we'll go out into the large-scale structure of the universe where you can see the Sloan galaxies, and we'll just show you that right here. Okay, so you can see these sort of large voids and eddies. But WorldWide Telescope, really, I think the exciting part for me is really about the ability to do some of these things that we call guided tours. So guided tours are really paths within this rich data environment. So here's one that was created by Alyssa Goodman, who's an astronomer at the Harvard Center for Astrophysics.
But it's hard to see that because we're inside. Here's a spiral galaxy not far from us, about 12 million light years away, called M81. If we look at it in optical light, we see billions of stars shining together in a spiral pattern. If we look at the heat from M81 rather than the light, it looks like the false color orangey image we see here. This Spitzer Space Telescope image uses long wavelength cameras that can see heat, just like the one that took the picture of this cat. Galaxies are filled with tiny particles called dust.
Looks like video, feels like video, but it's not video. The problem with video is when you pause, nothing happens. When we pause, we're in the environment. So you're looking at M81, you can sort of get a sense of where it is. If you want to look at that galaxy from other telescopes, such as the Spitzer, you can look at those. You can see what it looks like in X-ray, where the high energy sources are. I mean, these tours are like a tour bus. So you're going around and you see something interesting, but if I find something that's interesting, I can get off the bus, I can jump on some of these other tours that relate to what are the things that we're looking at. If I'm interested in finding out more information about that particular object, if I was a kid doing homework, I can go look and say, well, tell me about that object in Wikipedia, and it'll go give me some information about that on Wikipedia. Or if I was an astronomer, I could go look up that at ADS, which is the Smithsonian Astrophysical Database, to do a query for all of the published papers that reference that particular object. Here's the most recent one from December of 2010. So that's just an example. We could sort of continue going where we were, but I think one thing that's particularly interesting about these guided tours is it provides a way to construct a path into these data environments and tell stories about places that maybe you weren't really aware of. I'm going to open up another tour here, and this is a tour that talks about data. And so this is about 18 months of earthquake data, starting from January in 2009 to the middle of 2010. And so we're looking at this data in 3D. Essentially, you're seeing the actual visualization of the magnitude and location of these earthquakes around the globe. So in it, we can swoop down into California, so we can all worry and see where the San Andreas is going. And it goes right through us down in California. But more interestingly, it's taking us on a path. I can stop here and start to explore some of this data. One example is, you can see that that was the Haiti earthquake we just passed by right there. Here's some large temple scale structures that you normally don't see when you're looking at thousands of rows of data. So you can see these patterns that are generally invisible. And because it's in this environment where it's totally interactive, what we can do is we can pause and we can start to explore this data, essentially drilling down deep, looking at some of these structures. And like before, we could drill into any of those individual data points to start to explore that. We'll take a quick look over down to Chile, and you can get a quick look at the earthquake that happened down there. And there's the earthquake and all of the related aftershocks. So this idea of guided tours, I think, has some really interesting implications going down the road. This is a tour that was created by some astronomers at Harvard Center for Astrophysics about John Huckra, who was a graduate student here at Caltech, and he unfortunately passed away last October, and this tour is dedicated to him. So one of the interesting things about these tours is that they can be hyperlinked to anything. And because this tour is 12 minutes, I can't show you all of it. But what I did do is I put in these little Caltech links in here so we can jump to portions of it so you can get a sense of the nature of the tour. So maybe we can turn that volume a little bit more. Thank you.
His principal goal was to learn the three-dimensional distribution of matter in the universe, much as we know and understand the surface of the Earth. Here is a three-dimensional view of the top of Mount Hopkins in Arizona, the site of many of John Huckra's astronomical observations. Adding altitude measurements to a two-dimensional map of this part of Arizona gives a 3D view. In the same way, adding distances inferred from galaxy redshifts to a two-dimensional map of the sky can make a three-dimensional map of the universe. As a graduate student at Caltech, John made many lifelong friends among the graduate students, including me. He mastered the use of telescopes, and he used them to study galaxies. With Walt Sargent as his mentor, John observed a selection of what he called little blue galaxies, like Markarian 533, seen here. One study of Markarian galaxies got John into a heated discussion in the journal Nature.
There are many references to papers in here, and all of them are linked directly to the paper.
Another harbinger of things to come. After his PhD, John moved east to the Harvard-Smithsonian Center for Astrophysics.
We can do animation in here, too.
John and a number of his young colleagues were deeply influenced by Jim Peebles' desire to understand the origins of. If we color code the same first strip galaxies in a 3D view of the universe given to us by the modern Sloan Digital Sky Survey, we can see how a strip on the sky translates to a wedge in 3 dimensions, as is the Great Wall.
So this is a mapping of CFA 1 and 2 into the larger Sloan Digital Sky Survey.
The Sloan Digital Sky Survey is shown here. The Sloan survey measured redshifts
so I'm going to
for
pause
hundreds
this
of
tour
thousands
for a
of
second.
galaxies.
And what we can do is, because we're live in the Sloan galaxy itself, I can right-click and bring up this little finder. And suppose I was interested in that little lonely galaxy out of a million there to get some information about it. It goes and does a lookup in the Sloan site. And here we have the image of the galaxy that you can download, the spectra. Here's the redshift. You want to take a more detailed look at that spectra, you can do that. You can do that for any of those galaxies that we're looking at here in this virtual space. So let's jump over to here.
Nobody worked harder at its craft or enjoyed it more than John Huckra. He helped us all see more clearly the universe in which we live.
So some of the exciting things, I think, about the tour is in terms of thinking about how we can create these annotated streams of metadata that are rendered in real time to give us these rich experience, but taking people through data. As we start thinking about big data and essentially internet scientists, how we can use these tools to sort of bring them into the fold. The last bit before I have no time remaining is be sure to check out Project Tuva, which is the Feynman Messenger lectures in a rich interactive player. Thank you.